We're going to be solving problems involving projectiles. For this question, to determine the time it takes for the ball to hit the water, you may think we need to use this equation because we've got a velocity and we've got a distance, a displacement. However, we cannot use this equation because this equation is for constant velocity and that only applies to horizontal motion. So we can only use horizontal components. And so yes, we've got the horizontal velocity, but this is a vertical distance, displacement, and we need the horizontal displacement to use this equation. So we cannot use this equation for horizontal motion, so we need to look at vertical motion. And vertical motion, we use the Suvat equations, the equations for uniform acceleration. So S in the vertically is 20 meters. Vertically, U equals 0. The initial velocity is 0 because the ball is being projected horizontally. Final velocity vertically, we don't know. The vertical acceleration is due to gravity, so is 9.8 meters per second squared. And we're trying to determine time t. So we need an equation that links S, U, A and t. So that is S equals ut plus a half at squared. And because U equals 0, the equation simplifies to S equals a half at squared. And so if we rearrange to make t the subject and substitute in our values, we get the time taken as 2.0 seconds. To determine how far the ball lands from the cliff face, that means we're determining the horizontal displacement. So we use the equation for constant velocity, S equals ut. So the U is the 5.0 meters per second because that's our horizontal velocity, which is constant, and the time that it took for the ball to land was 2.0 seconds. So the horizontal displacement is 10 meters. For this question, we have a horizontal projection, but now we have the horizontal displacement and not the vertical displacement. So to determine how long it takes for the ball to hit the ground, we can use the equation for constant velocity in the horizontal direction, as we have the horizontal velocity and we've got the horizontal displacement. So the time taken will equal 3.0 seconds. To determine the height of the cliff, which is our vertical displacement, we need to use vertical motion, so the equations for uniform acceleration. So the Suvat equations. So S is our h, which we're trying to find out. The initial velocity vertically is 0 because we have a horizontal projection. The final velocity vertically we do not know. The vertical acceleration is due to gravity, so is equal to 9.8 meters per second squared. And the time taken to cover the height h, we worked out from the horizontal motion to be 3.0 seconds. So we need an equation that links S, U, A and t. So we're using S equals ut plus a half at squared. And if we substitute in the values, we can determine h, which equals 44.1 meters. Part C, we need to determine the speed of the ball when it reaches the ground. Well, we know horizontal velocity is constant, so when it reaches the ground, the horizontal velocity will be 10 meters per second. In order to find the vertical velocity, we need to use the equations of uniform acceleration, the Suvat equation. So S equals h, which we worked out to be 44.1 meters. The initial velocity vertically is 0. We're trying now to determine the final velocity. The vertical acceleration is due to gravity, so is equal to 9.8 meters per second squared. And the time the ball reached the ground, we worked out to be 3.0 seconds. So you can use any Suvat equation that has V in the equation. I'm going to use the one that links U, V, A and T, which is V equals U plus AT. And when you substitute in the values, you get the final vertical velocity being 29.4 meters per second. However, the question is asking to determine the speed of the ball when it reaches the ground. We have the horizontal velocity and the vertical velocity when the ball reaches the ground. So to determine the speed of the ball, we need to find the resultant velocity of these two vectors. And so that means we use Pythagoras. And so the resultant velocity, which is the speed of the ball, equals 31 meters per second. For this question, we need to determine the maximum height of the ball, which is a vertical displacement. So we need to use the Suvat equations for vertical motion. So S is what we're trying to determine, the maximum height. The initial velocity vertically will be the initial component of the velocity in the vertical direction. So the vertical direction is opposite to the angle, so that means we use the sine term. So the initial velocity vertically will be 7.0 sine of 30, which is 3.5 meters per second. The final velocity at maximum height in the vertical direction will be 0. The acceleration vertically is due to gravity, and because it's acting downwards, it's equal to minus 9.8 meters per second squared. And that's because we took our initial velocity to be upwards, so positive. So the acceleration which acts vertically downwards is negative. And we do not have the time taken. So we need an equation that links S, U, V and A. So that is V squared equals U squared plus 2AS. And so we need to rearrange the equation to make S the subject. And if we substitute in the values, we get S, the maximum height, equals 0.625 meters. So for this question, we need to determine the range of flight, which is our horizontal displacement. So we use the equation for constant velocity in the horizontal motion. So we're trying to find SH. However, we can't use this equation yet because, yes, we have the initial velocity horizontally, but we don't have time t, the time of the flight. So we need to first determine the time of flight using the vertical motion. So we need to use one of the Suvat equations. So vertically, the time of flight, S will equal 0 because the initial displacement and the final displacement vertically is the same point. The initial vertical velocity will be the initial component of this velocity vertically, so is 10 sine 20. To determine the final velocity vertically, if we assume a symmetrical path, then the ball will land with a velocity of 10 meters per second at an angle of 20 degrees from the horizontal. And as it's in the opposite direction vertically, we will show this as a minus sign because we've taken the vertically upwards to be positive, so vertically downwards will be negative. So the final velocity will equal minus 10 sine 20. The acceleration, which is due to gravity, will equal minus 9.8 meters per second squared. And we're trying to determine t, the time of flight. So we can use any of the Suva equations which has t in the equation. However, I'm going to use the equation that links u, v, a and t, which is v equals u plus at. And if we rearrange the equation to make t the subject and substitute in the values, we get a time of flight as 0.70 seconds. And so now we can use the equation of constant velocity for horizontal motion to determine the horizontal displacement. To determine the horizontal velocity, we will resolve this component in the horizontal direction, which will give us 10 cos 20. And if we multiply that by the time of flight, we get the horizontal displacement, that is the range of flight, equal to 6.6 meters. Alternatively, you could determine the time it takes to reach maximum height. So at maximum height, the final velocity will be 0 in the vertical direction. So we'd use the equation v equals u plus at to determine the time it takes for the ball to reach maximum height. And then the time of flight will be double this value, assuming a symmetrical path. And then again, we use the equation of constant velocity, horizontal motion, to determine the range of flight. For this question, we know the horizontal displacement and the time it took. And we need to find the initial speed of the football, u. So we can use this information to first find the initial velocity in the horizontal direction. So use the equation s equals ut for horizontal motion. And if we substitute in the values for the horizontal displacement and the time taken, we get a horizontal velocity of 18.7 meters per second. As it took 3.0 seconds to cover this distance of 56 meters, then half this time will be the time to reach maximum height. And so we can use this time to work out the initial velocity in the vertical direction. So for vertical motion, we use the Suva equation. So vertically, we do not have the displacement for maximum height. We're trying to determine the initial velocity in the vertical direction. The final velocity in the vertical direction at maximum height will be 0. The vertical acceleration will be due to gravity, but because it's acting downwards in the opposite direction to the initial velocity vertically, we'll have that as minus 9.8 meters per second squared. And the time taken to reach maximum height is 1.5 seconds. So we need an equation that links u, v, a and t. And so that's v equals u plus at. We need to rearrange this equation to make u the subject, and substituting in the values gives us an initial vertical velocity of 14.7 meters per second. So we have the horizontal velocity and we've got the vertical velocity. So to find the initial speed of the football, we will need to use Pythagoras, and that will give the initial speed to be 23.7 meters per second. And the angle of projection, theta, we can use trigonometry and the tan term, which gives us an angle of 38 degrees.